If you want to save some game data, there's two steps to take. The first one is mandatory, but the second one is optional. First, we need to do something called serialization, which means convert your game data, whatever that might be, into a string, or a byte stream is what they call it, right? But it's basically a string. So you might have tons of integers and booleans and tables and arrays, whatever. We're going to convert that all into a single string, which will be considered serialized. And then the second step, which is optional, is we can encrypt that string. Because if we save that string to a file, let's say, for example, people in your game can collect gold coins. Well, somebody could just open that file and see gold coins equals 10 for maybe 10 gold coins. They might just replace that 10 with a million. And then when they open the game again, they'll have a million gold coins. So what we want to do is encrypt that so that if they open the file, or if they, that's for a single player game, or if it's stored in the cloud, they could send a false message to the server, right? So they could spoof message us. And so they won't be able to do that if we encrypt it. So that's sort of the second step as a little extra security, and it's really easy to implement. We're going to be using an example from Unity, which is a free game engine. But this principle will apply to basically any engine that you might work in. In addition to that, I've got time codes in the description of this video if you want to jump around, but it probably will make more sense if you watch the first part first and the second part of this video second. And one more thing, all of the source code is linked in the description of this video, so feel free to just download it and start playing along if you prefer. So I'd like to start with talking about the data at hand, and I have a little example here with some different data types. So let's say this is the information you want to save for your game. Maybe they've got a string username, they've got an integer to represent their power level, and then they've got a custom struct here called weapon info with the variable name current weapon. So this is the current weapon that maybe the player was holding before they save the game. And weapon info is defined as a struct with two parameters, two values, two data types. It's got a string for the weapon's name, and it's got an integer for the weapon's damage bonus. Now, what might this data look like when you fill in the values? Well, here's an example. Let's say the username is a string, right? So that might translate to just the string Fat Bob, right? Basically just a character array. Then the power level might be 9,000. And then the weapon info may similarly have a string and an integer. So maybe that's Dirty Knife, and the damage bonus for Dirty Knife is 5. So the first question I have for you is, how might you serialize each of these fields? The answer being, well, for the string, we don't really need to do anything. Fat Bob as a string is perfectly serialized as it is. So we're just going to have it the same way, basically. The next thing we have is the integer 9,000. Now, there's a number of ways that we can serialize an integer, but probably the easiest way, if you've seen this before, you probably have, is you might have something like int num equals 5, and then you do string s equals empty string plus num. So we're just basically implicitly casting it to a string there. That is a great way to do it. If you have particularly long numbers, or you know special things about the data, you might be able to condense that number through a variety of methods. A very popular one, particularly for sparse data, where you might have a lot of zeros, is called run length encoding, RLE. So I would encourage you to take a look at that if you're dealing with a ton of numbers and you need to squeeze them down into a more reduced memory size. Okay, so now let's talk about a little bit of a harder question. How are we going to serialize this custom struct weapon info? Now, it's got two parts that we know how to serialize. The weapon name is simple enough. That just translates to Dirty Knife, right? It's exactly what it is, just like Fat Bob was a string already. The damage bonus, same thing. It's an integer, so we can, do a little cast like we did before to just convert that to a string. But what's not clear is how are we going to convey that this is not just another string and another integer? How are we going to convey that this is the weapon info that's being saved? That's a question I want you to think about for a little bit. We're going to get back to it. But one of the things that I want you to keep in mind always when you're serializing, this is the number one question. It's the one thing that you should come away from this talk with, is we always want to be concerned with, can we reduce the data? So we talked a little bit about how you might take a really big number and squeeze it down with something like run length encoding. But is there any way that we can reduce the struct itself? So in this example here, we have weapon info, which has a string and a damage bonus. Well, let's say that all of the dirty knives in your game have a damage bonus of 5. Maybe whenever you pick up a dirty knife, it always has damage bonus 5. Maybe the diamond knives or the legendary knives have damage bonus 10, but all the dirty knives have damage bonus 5. Well, if that's the case, we don't need to save the damage bonus because it's implicitly being conveyed by the name of the weapon. Every dirty knife has damage bonus 5, so you don't need to save that. You can just look it up from some table. And in fact, that's what many games do. They'll have lookup tables, and instead of saving all this information for a specific weapon, they might just save the weapon's ID or some sort of other way that they can refer to it. So in this case here, we're going to have a weapon ID that's an integer, and that simply tells us what to look up inside of this little nifty table here. So I've got a table where the weapon ID is the leftmost column, and you can see that that row corresponds to the dirty knife name with a damage bonus of 5. So that might be sufficient for your game. You might just be able to save the integer weapon ID, and then you could look up what's the name going to be and what's the damage bonus. But sometimes the data is not reducible. Here's an example of that. In this case, I have durability as a field. So durability, let's say that is basically how new is the weapon. And every time you use it, it might tick down a little bit. So let's say you got your dirty knife, it's brand new from the store, 100 durability. But now if I go to cut a loaf of bread, oh no, now it's only 95 durability or something like that. If that's the case, we need to track that because it's not sufficient to look up a weapon ID because we don't know what durability your specific dirty knife was in. So in that case, the durability would be considered not reducible. We have to keep that information. So we may be able to simplify it a little bit. So we went from like 2 fields to maybe just 1 field. And of course, this is an integer instead of the weapon name string. So that's significantly smaller when you think about how you have to save that, the size of that information. Strings are typically not reducible. You know, the serialization can't do that on its own. So it really is up to you to come up with an algorithm for your game to determine how can I reduce this information as much as possible. And it's important because not only does that incur a larger file size if you have to save more information for your save data, but if you're sending this over a network, you have to pay for that, right? Not only in terms of, maybe you're paying AWS for how much data you're sending over the internet, but maybe you're also paying in terms of time for how long it takes for that information to get to another player. So it's always better to use less information if possible. We want to really reduce the information. So let's say this is the best I could do. The best I could do was an integer for the weapon ID and an integer for the durability. So now, if that's the case, how would you serialize it? Well, one approach might be to just write the string for the weapon ID and then the string for the durability, and then maybe separate them by commas, right? So that might be a perfectly fine way to do it. And if you want to create your own custom serialization algorithm, you could certainly go ahead and do that. However, it's a lot of work to do manually. And there's another catch here. What would happen if we added a new field into the middle here? You know, maybe there's a new integer here called weapon power level. And let's say that scales over time, so it's not something you can squeeze into the ID. Well, if this weapon power level is another integer, let's say it's 4, for example, how are you going to add that to the serialization structure? Maybe you could just pop it in here. However, if that's a new version of the game, what are you going to do with all the previous save data information that only had the ID and durability? Well, then, if this is written down, like let's say there was a previous save file that was just 1 and 10. Well, the serialization algorithm that you came up with, it might go through this and might say, okay, 1 is the weapon ID, and then 10 is the power level. Because it maybe doesn't have anything saved for power level yet, so there's a sort of like a missing number in the middle, and it might misinterpret that as being the power level when it's really the durability. So this is just something for you to consider. What a lot of serialization algorithms will do is they will also specify the field in addition to the value. So instead of serializing just 1, they'll often say something like ID : 1 and durability : 10. That way, if you add something else like a power level, when you read this in, you'll say, oh, okay, there's no power level saved here. That way we don't have to guess whether or not the second number is the durability or the power level, right? So we're going to see that come up in an example with JSON in just a moment. But it's a question I want you to be thinking about constantly. What is the minimum amount of information we need to represent this data? So in the case of serialization, in a human readable format, you may want to include the field name, but it's also very common for you to serialize data into a binary format, in which case you really need to know the order and exactly how many parameters there's going to be. Otherwise, you might do exactly what I showed in the example there, where you misread some of the information. For example, you mistake the durability for the power level. Something like that. Okay, so let's, enough of that theory. Let's jump into some examples here in Unity. So Unity, free game engine, awesome game engine, only sometimes a piece of a mess. But I have a very simple scene here where I've just got a background image and some text, and I'm going to be displaying some information there. And I've also got a little script in my scene. Let's check that out. So this script is called Serialization and Encryption. Again, it's linked in the description of this video. And we're going to be running some tests here to show you the process of serialization, and then we're going to get to something we haven't even touched upon yet, which is encryption. So let's pop that open, this little script, and I'll show you that we've basically got 3 parts here. The first part is we're going to initialize our data. The second part is we're going to serialize and encrypt the data. Then in the next part, we're going to deserialize and decrypt the data. So basically, you'll be able to see the whole process of how the data might be hidden, and then we'll send it over a network or something, or save it to a file, and then I'll show you how we might read it back and rehydrate the data so that now you can use it in your game. When you load the game, basically that whole process. Obviously, if we encrypt it, it's no use if we can't decrypt it. So that's an important step to show you. Yeah, so let's hop into it. So the first thing is I've got a little struct here called weapon info, a little bit similar to the example I showed before. In this case, though, the weapon ID is a string. So we've got a weapon ID. I've got it defined up here, actually, so let's pop that open. So the struct called weapon info is defined over here. And it's at this point I want to show you a common mistake that people make when they're coding this, particularly for Unity. You have to always use the system.serializable keyword at the top of your struct. And this is the same as a class. So you're also going to need this at the top of a class if you want a class to be serializable. So you just pop it up there, and then you're good to go. So then it's going to be serialized. So that's going to come up later. And yeah, so let's jump into the fields now. So we've got a string for the weapon ID, a little bit different than my earlier example where we used an integer. And then for the durability, we're going to have an integer. So those are the 2 parameters here. And I just wanted to highlight another common mistake, since these are some pretty basic data types. I want you to keep in mind that it's always important for you to reduce the data types before we serialize. Something that has any internal bookkeeping, like a map or dictionary, is not going to serialize well. So you want to first convert that into some sort of array. So for example, with a dictionary, it's common for you to serialize that as maybe an array of keys, an array of values, right? That's a simple way to do it. And then you recompose it when you want to use it in the game again. Because advanced data types are often just not supported for the serialization methods we're going to be using. It needs to be something that's a common data type everybody knows. So for example, a vector 3 is often not going to be good. It's a little bit too complicated. And so what people will often do is they will break their vector 3 into a position X, a position Y, a position Z. They will then take those 3 pieces of information, they will serialize it, and then when they deserialize those 3 pieces of information, they'll create a new vector 3 using the X, Y, and Z that they just deserialized. So if that makes sense, basically they're just breaking it into small pieces and then putting those pieces back together when the process is time. Okay, so that covers that other little mistake here. So we've got the weapon info defined, and we are going to create a little weapon info right here. So I've created a weapon info with the ID being the string dirty knife, and the durability I have set to 5. And I have now printed into the text field the default serialization method. So if we were to just do .toString on the created weapon info, what would come up? Well, what do you think? This is the default for Unity. Let's check it out. I'm going to push play here. And Here you go. So the default serialized version of weapon info is just the text weapon info. So that is laughably unhelpful, right? That's not going to help us at all. It's just the name of the struct. It doesn't tell me any information about what's inside the struct. So the default toString method is not going to be sufficient for serialization because we need to know its name, dirty knife, and we need to know its durability of 5. So as I mentioned before, you could come up with some custom methods of how you might serialize it, but there's actually two really great free, easy to download methods that are popular online that I'd like to show you right now. So the first one is called XML, and XML is, I think, probably still the most popular. It's used all over on the web, but it is a little bit long. And then the second method is JSON, which is probably gaining the most popularity these days. It's the hip function to use for sure. So that actually is built into Unity with something called JSON utility.json.toJSON. So that's simple enough. The serialize XML is not built into Unity by default. So I included a very simple script which will serialize text into XML for you. So if you want to use that code, you can use it. Maybe, for example, you have to use XML for one reason or another, then this is perfectly fine to use. And similarly, there's a deserialization method included here as well for your use. So let me show you what that example looks like. Let's check out what does the created weapon info look like if we serialize it using XML. So I'm going to go into my method here. I'm going to check the box serialize, and I'm going to check the box using XML. Let's see what happens here. And okay, so here is the result. And there's actually a lot of information on the screen there. So I'm going to add some spaces just so that it's a little bit easier for us to read. And check it out. So as you can see here, the dirty knife text is printed, and so is the durability value of 5. And on either end of those values, they've included the name of the parameter that they are serializing. So similar to, as I said before, you need to know which section is which if you're not going to go with if you want to have a human readable format. Well, that's exactly what they've done here. So we can see, okay, the weapon ID is defined as dirty knife and the durability is 5. There's also a little bit of garbage at the top here, which just tells us what serialization method we use in the encoding and stuff like that. So this is what XML looks like if we were to serialize it. Obviously, this is a lot more helpful than the default method, which didn't tell us any information at all about the weapon ID and the durability. But now let me show you an alternative, and this is with JSON. So I'm going to uncheck this box, so we use the JSON implementation. And you may be shocked at how simple it looks now. So this is a lot easier to read, a lot less text on the screen, and it's got the same information. So we've got the weapon ID here, and the dirty knife, and then the durability, and then the 5. So simple enough. What's going on here is it's only repeating it once, and as you can tell, it has the name of the field, then a colon, then the value of the field. So this is why people love JSON, because it saves them a lot of space, because it takes up less space to write, certainly compared to XML. So that covers serialization, simple enough. And now we're going to talk about let's cover deserialization while we're still here, and then we'll go into encryption, which is a little bit more complicated. So the serialization method I showed you is simple enough. We just serialize to XML, or we JSON.toJSON, simple enough. And then for the deserialization method down here, it's very similar syntax. We're going to do deserialize XML with the string data that we've received. So basically, I'm just reading in the string data from the text that we just wrote. And similarly, with JSON utility, you could do dot from JSON with the string data. So there's nothing too complicated here, folks. It's simple enough to drop this into your game, whether you want JSON or XML. Very easy to do, and it can also support Unicode, which is very important if you might want to be saving information in Chinese or something like that. So that is serialization, but here's the problem. If we have a save file that says weapon ID, dirty knife, and durability 5, well, the player's probably going to have a pretty easy time changing that information, right? They might sneak into that file. They might go to durability and they might say, oh, I know what I'll do. I'll change durability to 999999999, right? Something crazy like that. Or maybe they'll do that with how many gold coins they have. So now they're super overpowered because they were able to read the data format and they were able to mess with it, right? They were able to hack into it. So what we want to do now is encrypt that information so they won't be able to make sense of the data, and they won't be able to hack us as easily. So how do we do that? Well, there's a lot of ways to encrypt data, just about as many ways as there is to serialize data. But the gold standard, the thing that the NSA and all the corps use, is called AES, the Advanced Encryption Standard. And that's the example that we're going to be using here. Now, I find a lot of great tutorials on the internet about how to use AES, but also a lot of really bad ones. A lot of people who don't know what the hell they're doing, making tutorials really confusing, where they're not using AES in the right way. So I'm going to be showing you a very simple implementation of AES, but I want you to keep in mind that this is just there's a lot of ways to do encryption, and this is just basically one approach, but it is it's a very safe and robust approach. So I would highly recommend this for your game or application or whatever it is you might be building. So what we're going to do is we're going to take the text that we've serialized. Keep in mind, right, it's in the serialized format now, and we're going to pass it into our utility function called encrypt AES. And that is a function which we have created. And I'm going to pop it open here. And this is what it looks like, okay? So this is a very small file, all right? We're only working with 150 lines. It's going to get a little bit complicated, okay? But I don't want anybody to freak out. I don't want anybody to be concerned. We're going to walk through this, and it's going to be a piece of cake. So AES uses two pieces of information in order to encrypt your data, right? You could think of it as let's say I give you a box, and there is two codes that you needed to use to unlock, right? Maybe it got two combinations on it, and you need to use the first code and then the second code to open it up. Well, the first code is a secret that me and you both know, but we can't tell anybody. And that code is called the key. The second code is a code which we send with the box itself. So if I'm going to give you a box with two combination locks on it, one of those combinations, that's the key. You know that by heart. And then the second one is actually written on the top of the box. And all you have to do is read that code from the box and use it to plug in. And so that code, the one that's written down, is called the IV, which stands for initialization vector. So there's two pieces of information we have here. We have the key and we have the initialization vector. And I'll talk about what both of those do. So the key is simple enough. I mean, we're all familiar with locks where you might have a secret key that you need to open up the lock. That's self-explanatory. But the initialization vector, what that does is it adds a little bit of randomness to the encryption. Here's an example of why we might want to do that. Let's say that you speak English and you want to decipher the very secret language of Spanish. And there's these two Spanish guys who meet up in front of your house every day, and whenever they meet, they say, hola, hola, and then they shake each other's hand or something, and then they go away. So you might be able to infer that hola means hello, because they always say that to each other when they greet. Similarly, somebody can do the same thing and determine your secret encryption. They can determine your key if you always use the same translation. So if you're constantly saying, chugga, chugga, chugga to your server to represent that a player has died, eventually players can determine that chugga, chugga, chugga means a player has died, right? Because it's always the same thing. So what we do is we have this initialization vector, which is a slight perturbation to the data, which changes it up in a little bit of a way. So for example, if I say, instead of saying hola to you, I say, I say hola, then basically I've told you a letter, and then I've said hola, right? So I've just added a on. Shit, I need to get an example here. So let's say instead of saying hola, let's pull this up. Instead of saying hola, let's say that I say to you, hey, hola. And then I say A Aola. And then next time I say B Biola or something like that. Or this is actually not a good example. Let's just say it like this. The initialization vector, the IV, it's going to add a little bit of a perturbation so that you never say hola when you mean to say hello. It's never going to translate to exactly the same thing. It's going to translate to something a little bit different. So it might be like yola or bola or nola. And it's gonna sound a little bit different. And the way that you're going to decipher the difference is going to be that the initialization vector is going to come with the information. So I frankly think I may not have done a great job at explaining that. So I'm going to try once more. What you want to do is you want to take the initialization vector and send it with the information so that the information is never encrypted in the same way. What we're going to be able to do is take that initialization vector and determine how that information was encrypted by using the initialization vector and the key that we both know. And so, again, the reason why we need that IV vector, if hopefully I haven't confused you too much, the reason why we need that IV vector is so that we don't always send the same information, because if we're constantly saying hola when we mean hello, people are going to catch on to it and they're going to realize that hola means hello. So we need to change it up a little bit. So that's the initialization vector, and that can be truly random for each message we're sending. So basically, each message is going to have its own initialization vector that's going to go with it, right? If I'm sending you a box with two combinations, I'm going to write down a random number on the top, and that's always going to be the code for one of the combination locks. So in order to generate the IV bytes, it's very simple. All we need to do is create a byte array. In this case, we are using 16 bytes, which is 128 bits, which is the minimum that you could use for AES encryption standard. They have more, but it's really unnecessary. 128 bits is totally secure. And we're going to be filling up that byte array with some random numbers, which are going to be unique to the message that we're sending. The next thing that we need is the key. Now, as I said before, the key is special and the key is secret. So we can't let anybody discover the key. So your key could be defined in code, right? You could just do this. You could just say the code is going to be 1, 2, 3, 4, 5, 6, 7, 8, and we need 16 numbers. So you would then do that again, maybe. And you know this could be. So you could do something like this, right? Maybe I made a typo here. Oh yeah, I made a typo right there. Is that it? Why is that not working? Oh, maybe I need to do it like this. Something like that. All right, so that could be your key. Just numbers 1, 2, 3, 4, 5, 6, 7, 8, and then you do it again, right? But the reason why we don't want to do this is because people can read your code. Okay, so when we start getting into the pro tier hackers, what they can do is, since it's a Unity game, we're sending them all the source code. They could actually open up this file, as they've done for games like Minecraft, etc. And you could then go to a section and you could say, hey, at some point they just write a whole bunch of these text to the file, right? And so they can read the file and they can realize, oh, this is the secret key. So it would be great if you don't do that. With the IV, that's why we generate the random numbers. But for the key, it can't be random. It can't be random because we need the client, whoever we're sending it to, we need in the future when we read this information, we always need to have the same number so that we know it needs to be the same key, basically. So what we can do instead is, well, we can get a little bit fancy. We can get a little bit tricky. So there's a lot of ways to do this. Here's one way that I came up with. It's pretty simple. What I'm going to do is I'm going to take a string from somewhere else in the game that doesn't change. So for example, this might be the name of the game. Once you create the game, the name isn't going to change. So this is just some constant string. And what I'm going to do is I'm going to go through each character of the string, and I'm going to just sum the integer representation of each one of those characters. So if I add all these up, this is basically the equivalent of hard coding an integer into the code base, right? I think this equates to something like 3,160. If you just write down, int sum equals 3,160, then that's pretty much the same thing. But the difference is that if somebody reads your code, they're going to have a much harder time determining what that number is if it's through an algorithm like this. So it's always better for us to have a little bit of obfuscation, a little bit of misdirection, than to just have the text plainly written down. And since the name of the game is probably used a whole bunch of places in the code, it might be a little bit confusing for the hacker to determine where it's being used, right? Ultimately, if the code is being saved in a single player game, there's always going to find a way to be able to hack it, right? Because you can always figure it out if it's locally, if you have enough time. The only way to really have it secure is maybe on a server where they never get to see the code. So an example of that might be if you have a bunch of people in a multiplayer game and they're shooting each other and sending messages to each other. Well, maybe the server for that game sends out the key at the start of the session. And they say, okay, for the duration of the session, we're going to be using the secret key. And then everybody knows that secret key. Then the session ends. And then a new key is created for the next session, right? So that would be much harder to decrypt because we're not using the same key always. But you need to be on the basis where basically both people know the key. So this is the best way to do it probably for a single player game. Okay, so if you have to store the key locally, then this is probably the best way to do it. And so what we do is we take that number and we use that as a seed to initialize the randomization. And then we do the same exact thing. We fill in the array with the bytes. And because we used a known seed, well, what that allows is for us to always get the same random numbers when we ask the random number, right? It's sort of like pi. If I say, what's pi? Those numbers are basically random, 3.14159. But we always know them to be like there's no real pattern to the numbers. It's just a defined sequence that you can refer to and I can refer to. So that's essentially what our key is. It's random in the sense that numbers don't have a pattern, but it's not random in the sense that we couldn't reproduce it. In fact, we need to be able to reproduce it predictably. And so that's exactly why we have the seed there. Okay, so those were the first two steps. Again, you could just copy the code, but it's really helpful to understand how it all works in practice. And so those are the first two steps to generate the IV bytes and to generate the key bytes. From here, it's basically smooth sailing. What we're going to do is we're going to create the AES symmetric algorithm. We're going to be tossing in the key bytes and the IV bytes, as well as an input buffer of any of the data we want to serialize. We want to encrypt. This is the data that's already been serialized. And then we're going to have the output buffer, which is going to basically, after it has transformed this information, it is going to have one big byte array of all the information we need. And then we need to send it along. So don't forget, we need to write that second combination on top of the box, right? We need to send the IV with the information. So in this case, I just have the IV at the very start of the string. But if you want to, you could put the IV at the back. You could put the IV somewhere hidden inside the middle. There's a lot of places you could put it. But it's more than safe to just put it at the front. And that's basically all we need to do in order to encrypt our information. So let's see what the result of that is. So if we go into here and we serialize and then we encrypt, let's see what that prints for us. Here is the result. So I have a little bit of some squares here. That is simply because it's in Unicode. So not all of the, so it looks like here, you can see in the log here that it's actually some maybe like Chinese or something. I don't know what that is, maybe Chinese or Japanese. So these are some Unicode texts that really don't make sense if you write it down. If you read this, it'd just be gobbledygook, right? I mean, you could see that it's STO0WCOTW, right? It doesn't make any sense if you read it. But this information is encrypted, and the benefit of this is that somebody now doesn't know how to convert that durability from 5 to 9,000. They can't simply go in here and add in a 9,000 here. That's not going to work because they don't know how they would need to add it. And that's exactly what we wanted. So now they're not going to be able to decrypt that information. Awesome. So the final process is to decrypt it. So I'll go back to my my starting list here. So we serialized it, we encrypted it. Now what we need to do is decrypt it using the decrypt AES method, which is very clean, very simple, only a few lines here. We need to first pull out that IV. Remember, we have that combination, that second combination written on top of the box. We need to read it off of the box so we don't confuse it with the actual data inside. In this case, I just put it at the very front of the data stream. So I'm going to take a substring of 0 to the end of the IV bytes. The amount of bytes we need to read is the length divided by 2. This is because we are encoding into Unicode, which is 64-bit all width. So that means that the characters are a little bit wider, and they're twice as wide basically than 32. So that's why it's the length divided by 2. So we're going to be pulling off those IV bytes into its own string. And then we're going to extract that into a byte array. And then finally, the encrypted string is basically everything after the IV bytes. So we're just going to do a substring starting at the end of the IV bytes to get the encrypted string. Then for our algorithm here, we're going to be sending in the key bytes and the extracted IV bytes, which are going to be unique to this message. And we're going to pop that into the input buffer here. And from the output buffer, we're going to then get the information we need. And then we're going to convert this from Unicode into a string that we can display to the screen. So let's take a look at how that works. So here I actually have it all printed inside of my console here. So you could see that we started with a ID of Dirty Knife. As I printed, I'll show you where I printed that, in case I didn't show it to you already. So here we go. With the very first method we did, we just printed the ID of the weapon. So that's how we got Dirty Knife to print first. Then we serialized this, so we converted it into this nice JSON format, which is, it looks like my screen is in the way. So then we converted it into this nice JSON format over here. Then we encrypted it into, a little bit of Chinese or a little bit of Unicode, so it's hard for people to read. They won't be able to edit it. Then we decrypted it, so we converted it back into that serialized form, which, looks exactly like the second step, basically, because they're going backwards now. And then the last step was we deserialized it into whatever struct it was. So in this case, it was called weapon info. So let's jump into that. In the code here, we deserialized it using XML or JSON, whatever you prefer. And I just chose to print the weapon ID of that derived weapon info again. So the derived weapon info is what we've basically determined the secret message had. And there is the weapon ID as printed. Okay, and that's it. So that covers serialization. It covers encryption. Hopefully it wasn't too confusing. Again, these topics are a little bit advanced, particularly AES. I mean, that's literally the gold standard that everybody uses. So you can imagine it's pretty secure. But if you'd like to learn more about that, I highly recommend diving into it. And feel free to go. Actually, I have, the better half of a decade ago when I was in high school, I wrote an essay that covers AES encryption. So that's at the end of my of mrventures.net/sidequest. If you want to pick it up, you could check out my this paper I wrote a very long time ago, which covers the matrix operations that actually go into AES. So if you're interested in and if you want to read my research paper on that, you can actually understand all the steps here, and I've got some cute graphics so you can really see it broken down step by step if you're interested. But there's a ton of really great YouTube videos with some cool interactive visualizations. There's a lot of great resources out there. Feel free to use whatever source is most comfortable for you. And ultimately, good luck. I really wish you luck in creating a game that you can save the information and then load it back later, and encrypt it as well if you choose to do so. If you make a game using this algorithm, I'd love to hear about it. So definitely let me know in the comment section below. Or if there's a similar topic to this one that you'd like me to make a video about, I'd be glad to do so. All right, good luck.